Welcome, fellow developers and IT enthusiasts. Have you ever felt that modern Java DevOps, while powerful, can be incredibly complex and time-consuming? From wrangling Maven dependencies to fine-tuning Docker files and debugging elusive CI/CD pipeline errors, the sheer volume of manual tasks and boilerplate code can often overshadow the joy of building innovative solutions. You're not alone. The constant pressure to accelerate delivery cycles while maintaining high quality often pushes teams to their limits. But what if there was a way to significantly ease this burden, to inject intelligence and efficiency into every stage of your Java DevOps workflow? Imagine having a super intelligent assistant at your side, always ready to help, whether you're writing code, generating tests, or even troubleshooting your CI/CD pipelines. This isn't science fiction anymore. Today, we're diving deep into how generative AI-powered developer assistants, specifically Amazon Q and GitHub Copilot X, are revolutionizing the Java DevOps landscape. These aren't just glorified autocomplete tools, they are comprehensive companions that understand context, generate sophisticated code, suggest optimizations, and even help you debug complex infrastructure as code. They empower you to focus less on the mundane and more on innovation, leading to faster development cycles, higher code quality, and significantly reduced operational toil. We'll explore a hands-on workflow, using a real-world inspired Java project, to demonstrate how these AI assistants seamlessly integrate into and enhance every phase of your DevOps journey, from local development to continuous integration and deployment. Get ready to transform your approach to Java DevOps. So, what exactly are these GenAI developer assistants we're talking about? Think of Amazon Q and GitHub Copilot X as more than just coding assistants. They are intelligent agents deeply integrated into your integrated development environment, or IDE, and increasingly, your entire development toolchain. Unlike traditional code completion tools, these GenAI powerhouses leverage large language models, trained on vast amounts of code and documentation, to understand your intent, context, and even the nuances of specific frameworks and APIs. This allows them to generate entire functions, suggest refactoring improvements, explain complex code blocks, and even write comprehensive test suites. They can interpret error messages and offer solutions, or even suggest optimal configurations for your build tools and infrastructure. For a Java developer, this means less time scouring documentation or Stack Overflow, and more time building. For a DevOps engineer, it means accelerating pipeline creation, debugging, and maintenance. They're designed to be proactive, anticipating your needs and offering relevant assistance before you even ask, truly acting as an extension of your development and operations team. To illustrate the practical power of these assistants, we've created a sample project called Java GenAI DevOps Companion. This isn't just a toy application, it's a carefully crafted representation of a typical Java project, designed to highlight specific interaction points where GenAI Assistance provides immense value across the DevOps lifecycle. The project includes a basic Java application, app.java, which performs simple calculations like factorials and provides timestamps. We've also included its Maven pom.xml for dependency management and build configuration, JUnit 5 test cases in apptest.java, a Docker file for containerization, and crucially, example CI/CD pipeline definitions, buildspec.yml for AWS code build, and a Jenkins file for Jenkins. Each of these components offers unique opportunities to leverage GenAI for increased efficiency and reduced complexity. This hands-on approach will allow us to see exactly how Amazon Q or Copilot X can become an indispensable part of your daily workflow, from the first line of code to continuous delivery. Let's start where most development begins, writing code. Imagine you're working on app.java and you need to implement a common algorithm, say, calculating the factorial of a number. Instead of recalling the exact loop structure or recursive logic, with a GenAI assistant like Amazon Q or Copilot X, you can simply type a comment like, // generate a method to calculate the nth Fibonacci number, or // implement factorial calculation for a given integer, the assistant, leveraging its vast knowledge base, instantly provides a complete, syntactically correct, and often optimized code snippet directly within your IDE. You can then accept, modify, or iterate on the suggestion. This capability drastically speeds up initial code generation, reduces boilerplate, and allows developers to focus on higher-level architectural decisions rather than routine coding. Beyond full method generation, these assistants also provide intelligent code completion and suggestions as you type, reducing typos, ensuring correct API usage, and improving overall coding speed and accuracy. It's like having an expert pair programmer constantly at your side, anticipating your next move and offering the most efficient path forward. Once the code is written, ensuring its correctness and reliability is paramount. This brings us to testing, a critical, yet often time-consuming, part of the development cycle. AppTest.java in our project demonstrates how GenAI assistants excel in this area. You can simply point the AI to a class or method, such as calculate factorial in app.java, and prompt it, // generate JUnit tests for the app.java class, covering edge cases, or // add a test for negative input to calculate factorial. The assistant can then automatically generate comprehensive unit tests, including test method stubs, assertions, and even specific scenarios like boundary conditions, like 0 and 1 for factorial, and negative inputs, like a negative number for factorial. Expecting an illegal argument exception. This significantly boosts test coverage, helps catch bugs early in the development process, and frees up developers from the repetitive task of writing basic test cases, allowing them to focus on more complex, integration, or end-to-end testing strategies. It truly transforms how quickly and thoroughly you can validate your code. Moving beyond application code, GenAI assistants extend their reach into the build process itself. Take our pom.xml, the project object model for Maven. This file, while foundational, can become quite complex with numerous dependencies, plugins, and build profiles. Imagine you need to add a new logging framework, like Logback, or configure a specific Maven plugin for code coverage. Instead of manually searching for the correct group ID, artifact ID, and version or wrestling with plugin configurations, you can simply ask your AI assistant, // add logback and SLF4J dependencies to pom.xml or // configure Jacoco Maven plugin for code coverage. The AI will generate the correct XML snippets, ensuring proper syntax and best practices. Even more powerfully, if your Maven build fails with an obscure error message, you can copy the error and paste it into the AI chat. What does this Maven error mean and how can I fix it? The assistant can often pinpoint missing dependencies, misconfigured plugins, or incorrect build commands, providing instant solutions that save hours of debugging time. Next up is containerization, an essential part of modern DevOps. Our Docker file defines the environment for packaging our Java application into a lightweight, portable container image. Crafting an optimized Docker file can be tricky, requiring knowledge of multi-stage builds, proper caching strategies, and base image selection for security and size. Here, GenAI is a game changer. You can prompt, optimize this Docker file for a smaller image size for a Java application, or add health check instructions to this Docker file. The assistant can suggest using multi-stage builds, like we have in our example, to separate build time dependencies from runtime requirements, resulting in significantly smaller and more secure final images. It can also recommend optimal base images, explain specific Docker instructions, and even help you tune JVM arguments within the container, ensuring your application runs efficiently and securely in any environment. This accelerates the path from code to deployable artifact, streamlining your deployment processes. Now, let's talk about the backbone of modern software delivery, continuous integration and continuous deployment, or CI/CD.